This is Geometry Lesson 9.5, Distance in Coordinate Geometry. So, say you have a diagonal line and you want to figure out how long it is. It's kind of hard to count little portions of boxes exact. So what we're going to do is turn this diagonal line into a right triangle, and then we can use the Pythagorean theorem to figure out exactly how long it is. I can easily count that that segment is 2 boxes long, and this one is 4 tall. So I can now use my Pythagorean theorem to just say 2 squared plus 4 squared, and then I throw a square root on that, and it'll tell me the length of the diagonal segment. 2 squared is 4, 4 squared is 16, 16 and 4 is 20. So if I root 20, I'll have the length of that diagonal. And that looks like it's 4.5 rounded. So it doesn't really matter if you draw your right triangle up or draw your right triangle down. All we need is how far over and how far up. And since we're counting the distance, it's not really going to have a negative or positive value. So this is 2 long, and that is 8 long. So 2 squared plus 8 squared, that's 64 and 4, so 68. And we can root 68 to get us the length of the diagonal. And that looks like 8.2. And last one, let's go this way just for fun. How far over, how far up? 6 up, 8 across, 6 squared plus 8 squared, that's 64 and 36, that's 100. And the square root of 100 is 10. Don't even need a calculator for that one. So this diagonal segment is 10 long. Now, say you're given points and you wanted to figure out the length without having to graph those points, count how far over it is, then do the Pythagorean theorem. Like, I wouldn't want to plot 15 over 34 up, 42 over 70 up, have to count out all those spaces. But if I just subtract my x values and subtract my y values, that's actually going to give me my horizontal and my vertical measurements. And as long as I'm squaring and adding and square rooting, why don't I just do that all in one giant step? So if I subtract my x's, that'll give me my horizontal distance. And I'd want the square of that added to my vertical distance, which would be the difference of my y's squared and added together. Square root that whole thing for good measure, and that's my distance formula. One thing I do want to point out is if you're using one of my calculators, it puts a parentheses here automatically. And that's separate from the parentheses you need on your x distance. So, and then there'd be one more here to close that parentheses. Depending on your calculator, you may have a double there, you may not. But mine, definitely you need the double parentheses there. So I'm going to label x1 and y1, x2 and y2, and I can sub those values into my distance formula to see how far it is from point A to point B. So we're going to start with the distance is the square root of 42 minus 15 squared plus 70 minus 34 squared. And if I type that whole thing in my calculator, it's going to do my horizontal distance, my vertical distance, it's going to square them, it's going to add them together, it's going to give me a square root, all in one giant step. That's not what I wanted. Okay, so square root, that's my auto parentheses, so I do need my second parentheses on my difference, plus my second difference gives me a total distance of 45 units. I'm afraid my battery's going to die, so I'm going to write this one out really quick. and leave it to you to try to get that into your calculator. That's x1. Oh, goodness. x1, y1. x2, y2. -7 minus 8 squared. 23 minus 15 squared. And if you get that whole thing in your calculator, it should give you the distance from point A to point B in that example. Good luck on the exercises, and please let me know if you have any questions.